Chapter 1, Stress Free Body Diagram Example. So in this example, if we know that the cross section for each bar in this configuration is equal to 10 centimeters square, we want to calculate normal stress in bar BC. So that's A, B, C. So bar AB and bar BC, these two bars are connected with a pin at B to each other, and a 10 kilonewton force is applied at somewhere with a distance of a 3A from A and 1A from B. The angle between those two bars is 30 degrees. We want to know what is the normal stress, and normal stress is just sigma. So that's FBC over area for bar BC, which is provided to be 10 centimeters squared. So let's see how can we solve this problem. So if you look at the forces, we do have AY, CY, and 10 kilonewton at a some distance as like A from a point B. So if we develop the summation of moment about point B goes zero, because that's a pin, and that says a negative A, that's a counterclockwise is the positive, so that's a negative AY times 4A, which is clockwise, that's why that's a negative, plus a 10 times 10 kilonewton positive times A, that's a counterclockwise 10 times distance A, that should goes by 0. Mhm. Because a C just passes through point B. So we don't care about the any of the components. So the C force C just passes through B, so that can be ignored. Mhm. And in that sense, it just says AY is 2.5 kilonewton. If AY goes by a 2.5, the summation of forces in y direction says Cy should goes by 7.5, which the summation of them would cancel out 10 kilonewtons at here, external load. So if you develop this triangle, it just says if Cy is 7.5 and this is 30, force at C is just, this is half of the hypotenuse, so RC goes by 15. RC is goes by 15. So as soon as we know what RC, force at bar BC, which is RC, is, we can simply get the, as soon as we know what RC is, that's 15 kilonewton, and RC is the force inside this rod, that's RC. Sigma BC is just force inside the bar over cross-sectional area, which is 10 square centimeters squared. So in that sense, sigma is just simply force over area. We have a 15 kilonewton, 10 cube newton over 10 centimeter square is 10 to negative 4 meter squared, and that gives you 15 to 10 to 6 newton over meter squared, and that's a megapascal. Newton over meter square is Pascal, and 10 to 6 is a mega, so that's a megapascal, and sigma BC is 15 megapascal. That's an interesting problem, and then just go a step farther, just calculate normal stress in BC, in bar BC, the same. If 10 kilonewton force, it just simply moves from its location to pin B. So if we just replace our force, instead of being exerted at a distance of A, it just come all the way to the right and applies at pin at B. Let's see how then we can solve the problem. Now in this condition, again, we have a y and cy, and summation of moment about point B again goes 0 in the pin. So that gives ay times 4a goes to 0. Mhm. So ay is 0. Mhm. This force is just passes through the point B, so exert no moments. Mhm. And then ay times 4a is equal to 0, because there is no moment at there is no other forces that we can apply. The other one, it just passes through the centroid. And because 10 kilonewton external is applied at B, summation of moment at B just gives us ay times 4a, and that equal to 0. It says ay itself is 0. If ay is 0, the only force summation of forces in y direction goes 0. It just says the all the 10 kn should be cancelled out by the only vertical force of cy, and that says cy is equal to 10 kilonewtons. Mhm. by by just simply moving the 10 kilonewton at here to the B, it just gives us a ay goes 0 and cy this time goes by 10 kilonewton. And if again you want to know what RC is, that's again a twice of cy based on a triangle rule. If this is cy and that's 10, so RC is 20. Mhm. Due to 30 degree. Hypotenuse is for a, if the opposite to 30 degree is 10, the hypotenuse is twice of that, that's 20. Mhm. So that was also an interesting problem which applies the uh, different effect of different moving the force in a different locations. Thank you.